Topic 5, some things we talked about earlier, cofunctions and complements. I know I mentioned cofunctions. Two angles are complementary, first of all, if their angles add up to 90 degrees. So if A plus theta is equal to 90 degrees, I meant to say alpha instead of A, that means that alpha and theta are complementary or complements. All right. And two angles are supplements or supplementary if they add up to 180. So if alpha plus theta is equal to 180, then alpha and theta are supplements. In a right triangle, the two angles are always complements. Because they add up to 90 degrees. The two angles are always complements. So we're going to deal with complements a lot more than we are with supplements. Okay? Therefore, we can consider pairs of trigonometric functions to be co-functions of each other. Co-functions deal with complements. Okay? Co-functions deal with complements. And we saw this a couple of pages ago when we looked at, here we go, when we looked at the sine of 30 being equal to the cosine of 60. They're co-functions, is what we mentioned. And we see that happening right here. The sine of an angle is equal to the cosine of 90 minus the angle. So if we look at that for the 30 degrees, the sine of 30 degrees is equal to the cosine of 90 minus 30 degrees, which is the cosine of 60 degrees. And that's exactly what we noticed before. Now, we're expanding that to say that that's true for any angles, not just the 30 and the 60. So it's true for any cofunctions. So it would also be true, for example, that the sine of 10 degrees is equal to the cosine of 80 degrees. That's a complement. I don't know what those two sine values is. It's true for the ones I know. It's also true for any other one. Okay, so these are some cofunction identities. We noticed that sine and cosine are cofunctions, and it goes both ways, of course, right? If sine goes into cosine, then cosine can go back to sine. We also noticed that the reciprocals of sine and cosine, secant and cosecant, were cofunctions, and of course both directions. And we also noticed that tangent and cotangent were cofunctions of each other as well, and in both directions. And again, we noticed that over here, where we said that the tangent of 30 and the cotangent of 60 were equal, so they're cofunctions with each other. Cool. So we're going to add those to our growing list of identities. We are going to have pages of identities. Check your pink sheets in the front of your notes. Pages of identities, which we need to be fluent in order to rewrite statements in terms of their identities, but we don't necessarily need to memorize them, but I need to be fluent with them and know to look for them, know what kind of identities exist. All right, so we're going to use some of these to evaluate. If I know the cosine of 20, then I know, because 20 and 70 are complementary, so that's going to be equal to the sine of 70 degrees. Cosine of 20 and the sine of 70 are equal. The cosine of 20 is also equal to 1 over what? Okay. Cosine's reciprocal function is secant, so it's 1 over the secant of 20. So I'm using both cofunction and reciprocal identities here. Cofunction and reciprocal. So we use the cofunction identity for the sine of 70, and we use the reciprocal for the 1 over secant of 20. Same angle here, so it just needs to be the reciprocal function. Different angles, so it needs to be the cofunction. All right, the tangent of 52 degrees is going to be equal to the cotangent of, I need the complementary angle. So first of all, 90 minus 52 is 38. So it's the cotangent of 38 degrees. Okay, the tangent of 52 degrees is equal to the cotangent of 38 degrees. Or That first one was a cofunction. Now the reciprocal function using the same angle, the reciprocal function for tangent is cotangent. So it's 1 over the cotangent of 52. So this is an interesting one. The cotangent of 38 is the same as 1 over the cotangent of 52, just because the tangent-cotangent relationship means that they're reciprocal functions and cofunctions of each other. Interesting. Okay, now we could decimalize these just to verify. I don't need to, but I could. But for example, if I did the tangent of 52, I can verify that that is the cotangent, which on a calculator I have to type as 1 divided by the tangent of 38 and get the same decimal. And so I can see, sorry about that, I can pull it down and see. But I do get the same thing. These would be easier to check had I used decimals. Okay, example 11. Given the following, compute all 6 trigonometric functions using just these decimals. Excellent. Okay. So the sine of 65 is 0.9. The cosine of 65 is 0.4, etc. Find and compute all 6 trigonometric function values of 25, rounded to 4 places. Okay. So the sine of 25, I need the cosine of 25, and the tan of 25. I'm just going to write down what I need first of all. The cosecant of 25, the secant of 25, and the cotangent of 25. I want all 6. What we want to use are the identities where possible. So I know values for the co-angle. So I know that the sine of 65 is going to match up with the cosine of 25. So without any work right there, I know that the cosine of 25 is 0.9063. And I know that the cosine of 65 is going to match up with the sine of 25. So that's 0.4226. Okay? Then I can do reciprocals here. If I know the sine value, I can take 1 divided by it and get the cosecant value. So I'm using reciprocal functions here. To get this one is 2.3663. If I know the cosine value, I can take 1 divided by it and get the secant value. 1.1034. Then I can do the tangent and the cotangent. Now tangent uses the fact that this is an identity that's going to be coming in the next section. I think I want to use it right now just for fun. It uses the fact that tangent is equal to, tangent of an angle of theta is equal to the sine of that angle divided by the cosine of that angle. This is going to be one of the most important identities. So we're going to use it even though it's popping up in the next section. So a little preview on this one. So if I had the sine and the cosine, I can divide those. 0.4226 divided by 0.9063 gives me 0.4663, and then I can do the reciprocal, 1 divided by that value, and I can get the cotan value of 0.1446. Okay. Quick check on those, and then we will discuss why I did them that way. So first of all, we have the sine of 25. Perfect. And then we have the secant of 25. Just checking a few of them. It matches up. Okay. One of the reasons for doing them this way as opposed to using the trig function is because that can be computed without having to know the trig functions. So use a basic calculator. If you knew those two things with a basic calculator without having to have a trig function, you can get those other identities. Sometimes I don't have a trigonometric calculator or decimals, I might have just a basic calculator, especially a computer. A computer can be programmed to do those things without having knowledge of the trigonometric functions.